All right, welcome back to Related Rates. Let's take a look at the next problem. So a boat is being pulled towards a dock by means of a winch 9 feet above the deck of the boat. The rope connecting the boat to the winch is being retracted, which means pulled in, at a rate of 1.5 feet per second. Determine how fast the boat is approaching the dock when it is 8 feet away from the dock. All right, so this one we're definitely going to need a diagram. So excuse my somewhat sad artwork here, but here's our dock. Here's the water. And we've got a boat. Woohoo! All right, what do we have going on? So there's a winch up on the dock, all right? Clearly you can see the dock is up higher than the deck of the boat. So here's the winch, which is a mechanism that will pull the rope in for you, okay? It's connected to the deck of the boat. So there's a rope here. So I'm going to call that R for rope, okay? And that rope is moving in this way. It's being retracted, okay, at a rate of 1.5 feet per second. All right, so the only way that I can work with a diagonal distance is with the distance formula or with the Pythagorean theorem. So I'm going to drop this down and create a right triangle here. And I'm going to call the horizontal distance x and the vertical distance y. All right, so let's go back and read and write down what we think we know. All right, so a boat is being pulled towards the dock by means of a winch 9 feet above the deck of the boat. So that means y is equal to 9 feet. All right. We're going to assume that that height stays the same, even though we know that waves would make it go up and down, up and down, up and down. But let's just assume it's calm water, okay? The rope connecting the boat to the winch is being retracted at a rate of the rope is dr dt, of 1.5 feet per second. All right, but it's being retracted, pulled in, that distance is getting smaller, so it's negative 1.5 feet per second. Okay, determine how fast the boat is approaching the dock. So that would be the rate going this way. So that means figure out dx dt is our unknown thing that we're going to be solving for when the boat is 8 feet away from the dock. That 8 feet is the x value. X equals 8 feet. All right. So what we really have is we have a shrinking triangle. Now, which of these things is fixed? The only thing that I didn't draw an arrow on is the y. So y is a fixed value. All right. And we said at the beginning, the only way to relate these things together, since it is a right triangle here, is to do the Pythagorean theorem. So I'm going to write that we have x squared plus y squared equals r squared. X is a changing thing, so it's going to stay in x. Y is a fixed value, so y squared is 81. And then I've got r squared. And now I'm ready to do my derivative, okay? So the derivative of this equation is, 2x times dx dt. The derivative of 81 is 0, equals, and then I've got 2r dr dt. If you want, you can go ahead and cross off those r's, the 2's, because they're on both sides. So I've got x dx dt equals r dr dt. And I can plug in all the numbers that I know. So I know that x is going to be 8 feet. I know that dx dt is my unknown value. R, I must have to know what r is, but I haven't written it down yet, so I'm going to come back to that in a second. Dr dt is negative 1.5. Okay, so the question now is, what's r? Now, where can I figure out the r value for this particular moment in time? I can go back to the original equation and use the Pythagorean theorem to figure it out, okay? So now I have x squared is going to be 8 squared plus y squared is 9 squared equals r squared. So r equals the square root of, let's see, that's 64 plus 81. 64 plus 81 is 145. And we don't have to worry about reducing because we're going to give a decimal answer anyway. So you are welcome to just leave it as is. That's going to fill in right here. And now I can solve for dx dt. So now I'm going to get dx dt is equal to, I'm going to rearrange it, negative 1.5 square root 145 all over 8. I can get the decimal approximation for that. If you type in negative 1.5 square root 145 divided by 8 on a calculator, you are going to get approximately negative 2.25, and then it's 7/8, I believe, so that rounds to an 8. And this is going to be also in feet per second because we're talking about a linear distance changing. It is a diagonal linear distance, but it's still linear distance. It's one dimensional, so it's just feet per second. It's not square feet or cubic feet. Okay, so that is the boat being pulled by a winch problem. Let me know what questions you